Hello. Thank you for tuning in to Ether Cosmology and Space Audits. And actually, I don't think we are live on ADL tonight, but thank you for tuning in. Tonight, we're going to be doing reading and research night. And as the standard disclaimer goes, this is for us to do live reading and research looking into topics, not necessarily presentations that we bring to, with a nice cohesive uh, presented format with an outline or anything like that. Instead, this is us doing live reading, live research, kind of raw, maybe not always the most entertaining thing, but it gives you a glimpse into how we read into these things. And so tonight, we're going to be reading uh, a paper, or we're going to be reading a section from Drude's book on optics, specifically a section on Michelson-Morley, or really, this is Michelson's interference experiment from 1881. So what I was actually just saying before we went live here is that this is going to be interesting because in 1887, when they did the Michelson-Morley experiment, the famous one where they did not detect any motion of the Earth, we always like to point out that they didn't go into that experiment blind, as if they didn't really know what to expect, and that relativity, special relativity, and not getting a fringe displacement within the framework of heliocentrism makes any sense. Like they didn't go in thinking like that. They knew what they were expecting. They were expecting a very specific fringe displacement. They understood the quote unquote velocity of light within their framework. And so when they didn't detect that, it was unexpected, very much so. And so this is, I think, good to look at something from 6 years before that experiment, showing what they were already, what they already understood and what they were, experimentally doing, 6 years prior.
Cool. Thank you for that intro. So yeah, without further ado, we'll get right into it. So the Michelson's interference experiment, the time which light requires to pass between two stationary points A and B, whose distance apart is L, or whose distance apart is L, is T1 equals L over C, where C represents the velocity of light. It will be assumed that the medium in which the light is traveling is the ether, or what amounts to the same thing as air. If the 2 points A and B have a common velocity of v or mu, sorry, g nu, sorry, if a velocity of nu in the direction of the ray, then the time of passage t prime 1 of the light from A to B is somewhat different. For the light must travel in the time t prime 1 not only the distance of L, but also the distance over which point B has moved in the time t prime 1, i.e., the total distance traveled by the light is 1 plus vt, or I'm sorry, nu t prime 1, so that, and then he gives the equation 45. If the light is reflected at B, in order to return at A, it requires a time of t prime. And then he gives the equation for that. For this case differs from the preceding only in this now that A moves in a direction opposite to that of the reflected light. Hence the time t prime required for the light to pass from A to B back at or back to A is from equation 45 and 46, so that repeating series. And then we're on equation 47. So provided the development to be carried only to the terms of the second order of V over C. I'm sorry, nu over C. Now, although the influence of the common motion of points A and B upon the time t prime is of the second order, it should be possible to detect by sensitive interference method. The experiment was performed by Michelson in the year 1881. The instrument used was a sort of interferential refractor furnished with two horizontal arms, P and Q, set at right angles to each other of equal length. See figure 57 on page 149. So maybe we'll come back to that. Two beams of light were brought to interference, one of which had traveled back and forth along P, the other along Q. The entire apparatus could be rotated about a vertical axis so that it could be brought into two positions such that P and Q coincide with the direction of Earth's motion. Upon rotating the apparatus from one position to the other, a displacement in the interference bands is to be expected. The amount of the displacement will now be more accurately calculated. Let the arm P coincide with the direction nu in Earth's motion, the arm Q perpendicular to it, and let A be a point in which P and Q intersect. The time T prime required for the light to pass through the length of P and then back given by equation 47. But by the time T double prime required for the light to travel, the travel length of Q and back is not simply T double prime equals 2L times C, for it's necessary to remember that the point of intersection A and that the 2 points, or that the two arms P and Q from which the light starts and to which it returns from the interval of the time T prime has its time changed in its position in space. Thus, the distance through which the point in A has moved to nu T prime in figure 107, the first position of the point A will be denoted by A sub 1 and the last by A sub 2 in order that the light from A sub 1 may return to A sub 2 after reflection at the end of arm Q. It is necessary for the reflecting mirror at Q to somewhat be inclined to the wave normal. The distance traveled by the light is 2s, and the relation holds. S2 equals L squared, and then plus 2 nu T prime, over 2 to the second. Also, if T double prime equals 2s times C, denotes the time which light is requires to travel the length of Q. That's not that's was that ratioing it? Is it of it or whatever? Anyway.
I don't know.
Now from 47, if the terms are higher than the second order, nu will be neglected. Okay, so now in terms 47, if the higher orders, then nu will be neglected. Hence, equation 49, where T prime, T double prime. Okay. If this difference in time were more than one period T, the interference fringes would be displaced just one fringe from the position which they would occupy if the Earth were at rest, i.e. if nu equals 0. Hence, if the displacement delta is expressed as a fraction part of the fringe, the results would be equation 49, where delta equals
Can you scroll back up real quick? I just want to see the ratio. So all T notable prime knows level 9 was. Oh yeah. So wait. You have L in both equations. Never mind. I was gonna say it's ratioing L to, but that, see, they have seconds to C. But then you have V squared over C squared in the one. T double prime is the you scroll back up a little bit more again. Sorry.
No, you're good.
Second squared equals L squared plus.
So the length of sorry, hold on. The length of, I think that was P and Q. Yeah, but the time T prime required for the light to travel, the length of Q and back is not simply T prime equals 2L over C.
Okay, so yeah, it is ratioing it then. You were right. That's just that's definitely what he's doing there, yeah.
Okay.
because that's
And
even what's in
then,
that equation, E prime or 2L over C, right? Yeah.
okay. All right, so will be neglected. Okay, if the difference in time were one whole period t, the interference fringes would be displaced just one fringe from the position in which they would occupy if the Earth were at rest, i.e., if nu equals 0. Hence, if the displacement delta be expressed as a fraction of the part of the fringe from the results from equation 49, then we have equation 50, in which v, I think, is the angle of aberration according to the page, and then he has the according to page 116, and then he gives the angle in arc seconds. Sorry, so z equals 20.5 arc seconds equals 20.5 times pi ratio to was that the speed of light squared equals 0.995 times 10 to the 4 radians. This displacement produced by turning the instrument from the position in which P coincides with the direction of Earth's motion to that which Q coincides with the direction would be 2 delta. But no displacement of the interference fringes was observed. The sensitiveness of the method was afterwards increased by Michelson and Morley by reflecting each beam of light several times back and forth by means of mirror. The effect of this is to multiply several times the length of P and Q, or of the arms of P and Q. So basically just extending the area of the device, increasing how long light has to travel to make it more sensitive. Each beam of light was in a way compelled to travel a distance of 22 meters, i.e. the length was 11 meters. The apparatus was mounted on a heavy plate of stone which floated upon mercury and could therefore be easily rotated about a vertical axis. According to 50, this was that like citation 50 or whatever, this rotation ought to have produced a displacement of about 2 delta equals 0.4 fringe, but the observed displacement was certainly not more than 0.02 of a fringe, the difference which might easily arise from errors in the observation. This difficulty may be explained by giving up the theory that the ether is an absolute rest and assuming that it shares in the Earth's motion. The explanation of the aberration becomes then involved in inseparable difficulties.
Wow.
Insuperable difficulty. Yeah, the aberration becomes involved in. Yeah. Another way.
Someone needs the popcorn, dude.
All right, you're in, or whatever. Or actually, you just did a bunch of popcorn. You want to read?
I'll meet the taco. I'm sorry.
Dude, that definitely sounded like you were tagging in, man.
Oh, yeah, I know. But then I was like, ooh.
Taunted me. Anyway, so let's see.
I can
when you finish that. When he finishes the taco, dude. You could take over, Toby.
Right. Another way of explaining the negative results of Michelson's experiment has been proposed by Lorentz and Fitzgerald. These men assume that the length of a solid body depends on its absolute motion in space. As a matter of fact, if the arm, which lies in the direction of the Earth's motion, were shorter than the other by an amount of L times, what is that, I squared over 2C squared prime, the difference...
It's nu.
Oh, it's mu, thank you. Or nu?
Nu, yeah, it's a V.
Thank you.
It's a thing that's supposed to be like a V for velocity or whatever.
Thank you. So L times nu squared over 2C squared. The difference in time, 2 derivative t minus the double derivative of t as calculated in 49. Equation 49 would...
Oh, wait, let me see. What was explains the negative result by the lack of accuracy in the adjustment of the apparatus. But according to a communication in which I have recently received from Lorentz, this objection is not tenable. If As is always, the case of observation is made with a telescope, which is focused upon the position of maximum sharpness of the fringe. Dang. So Lorentz shot that down.
Wow.
Said it was definitely accurate enough. GG.
Yeah, that's crazy.
Just put the old. Hold on, I gotta definitely coming back to that real quick. That's future ammo. All right, sorry. Go ahead.
All good. B, just compensated. An example, no displacement of the fringes would be produced. However, unlikely the hypothesis that the dimensions of a substance depend upon its absolute motion may at first sight seem to be. It is not so improbable if the assumption be made that the so-called molecular forces which act between the molecules of a substance are transmitted by the ether like the electric and magnetic forces, and that, therefore, a motion of translation in the ether must have an effect upon them, just as the attraction or repulsion between electrically charged bodies is modified by a motion of translation of the particles in the ether. Since v squared over c squared has the value of I-O to the negative 8.
10 to the minus 8.
Oh, I-O. That's a weird looking one. Has the value of 10 to the negative 8. The diameter of the Earth, which lies in the direction of its motion, would be shortened by only 6.5 centimeters. Whoa.
Yeah, crazy, huh?
Yeah. Whoops.
Oh, wait a minute. Is this wait a minute.
Is that it?
Dang, that is the yeah, that's pretty brief. And then he goes on to radiation.
Oh, I just finished my taco or whatever.
Likely story.
Like, hold on, I have another one.
You know, I only believe it because I hear the taco wrapper.
Yes.
Same, but once you have one taco wrapper, do you really need other tacos, or can you just reuse the same wrapper?
I might have ordered a box of tacos.
All right, well, let's check out the limit on optics real quick, because I guess that's it for Michelson-Morley. So, quick recap here. It was definitely, they're saying that this was regarding the 1887 instrument, right? Where they said, so the beginning part was the 1881 one. And then at the end, it gives the brief summary of the 1887, where they were like, maybe there were sensitivity issues, as Dude was saying. But then Lorentz, who was following Michelson's work since 1881, it was writing him back and forth on all of this stuff and keeping in contact. Even Michelson even puts his supplement in his 1887 paper for all the stuff that he gave him advice on. But yeah, anyway, he's like, it was definitely sensitive enough. You just put a telescope to the optical reader and you can definitely discern the fringe pattern. Right, because it was like a super small amount. It was 0.02 fringes, but, well within the confines, according to the lads.
You just use a telescope to look at it. He said.
Yeah, he said just put the telly on there, brother. Put a little telly on it. Yeah, so that's cool. So let's see what they thought about the limit of human optics.
Cool.
And this time, see where we're going here. That's not the right one.
Sounds cool, but
well, it sounds cool because you're gonna read it. So that's my favorite part about it.
Yeah, dude, you sound like you could use a break or whatever.
No, I just read slow, dog.
Right? But you sound like. Let's read. I got it.
That's how I normally sound. I don't know.
Mew, hold on. Just say Mew 3 times in a row. Mew, Mew, Mew.
Mew, Mew, Mew.
Yeah, you're right. That's it.
No, well, it's not even the right one. It's new. That's what was getting me because I'm used to saying the other one.
I'm just every time I hear it, I just think that stupid South Park alien game. Mew, 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 Mew.
Oh, never heard of her. 230. Oh, you want to start on the resolution?
Yeah.
Dude, it's literally a paragraph. Okay.
I got
Well,
it.
congratulations. You got that one, Shane. Thanks, bro. Thanks, dog. I really appreciate it.
It's like on my subject of expertise, dude. It's going to kind of derail these criteria on a resolution of the human eye. It's all me. I got it.
All right. Well, let's start with resolving power of a prism.
Hey.
Just to mess with you. Here you go.
All right. The resolving power of a prism. In connection with the above considerations, it is of interest to ask whether the resolving power of a prism exceeds that of a grating or not. Resolving power of a prism depends not only upon its dispersion, but also upon its width, which is perpendicular to the refracting edge. For if this width be small, each separate spectral line is broadened by diffraction. The joint effect of dispersion and cross-section of the beam upon the resolving power of a prism or of a system of prisms has been calculated by Rayleigh. Oh, I love that dude. In the following way. If by means of refraction in the system, P figure 74, the plane wave of incident light path wavelength A was brought into the position AB, optical paths from A sub O to A, B sub O to B are equal. A wave of other wavelength of whatever that is.
Lambda.
Lambda, yep. Plus distance lambda is brought, d lambda, is brought in the same time to the other position A prime B. So what is that? Sub something?
There you go. A prime to B prime.
Difference between the optical paths A sub O A prime and A sub O A. I see the distance A prime can be expressed as follows: A sub 0 A prime minus A sub 0 A equals A prime A equals dn times E. E1.
Ooh, nice.
In which dn denotes the difference between the indices of refraction of the prism for the two wavelengths. Yep. Lambda and lambda plus v lambda times n E1, the path traversed in the prism by limiting rays. This path is assumed to be the same for the different colors, an assumption which is permissible since A prime contains a small factor dn. Likewise, the difference between the optical paths B sub O and B prime and B sub O B, i.e. the line B prime, is B sub O B prime minus B sub O B equals B prime B equals dn E sub 2, in which E sub 2 denotes the path traversed in the prism by the other limiting rays of the beam. Dude, Rayleigh was a G, huh? It's all about this. Now the angle di, gangster optics. Now the angle di, which the plane wave A prime B prime makes us with wave AB, is the dispersion of the prism, is evidently di equals B prime minus A prime over B, which equals dn E sub 2 minus E sub 1 over B, in which B denotes the width of an emergent beam, the line AB. If the limiting rays A sub O A pass through the edge of the prism, E sub 1 equals O sub 1, and di equals dn over E over B, in which E represents the thickness of a prism at its base, provided the prism is set for minimum deviation. The rays within it are parallel to the base, and the incident beam covers the entire face of the prism. Same considerations hold for a train of prisms. If all the prisms are in the position of a medium deviation, E represents the sum of all thicknesses of the prisms at their bases. In order that such a train of prisms may be able to resolve in the spectrum of a doublet whose angle separation is di, the central images in the diffraction patterns, which are produced by each spectral line in consequence of the limited area O, note B, of the beam must be sufficiently separated for the opening of M.
I heard you giggle at doublet.
Yeah, it's like, come on. That's what we got to look at or whatever. Breadth B by the first minimum, and the diffraction image lies by on page 218. The angle theta equals lambda phi. What'd you say?
Phi.
Fucking phi. All right, so phi equals lambda b whatever asterisk is. What's asterisk in this context, dude?
Your guess is as good as mine.
Right, I'm just going to skip it. If then two spectral lines are to be separated, the dispersion di must at least be greater than this angle phi, which is half the angular width of the central band in the diffraction image of a spectral line, i.e. by the following must hold. dn equals E over B, which is greater than lambda over B prime, which is E is greater than lambda over dn. Hence, the resolving power of a prism depends only upon the thickness of a prism at the base and is independent of the angle of the prism. Thus, for the resolution of the two sodium lines of prism of flint glass, n equals 1.650, dn equals 0.000055, and lambda equals 0.000589 millimeters. At least 1 centimeter thick is required. But for the resolution of two lines of width d, is that lambda? D lambda equals 2, 10 to the 6th, which may be accomplished with the Michelson echelon or with a grading of 500,000 lines. The thickness of the prism will need to be E equals 5 times 10 to the 2 centimeters, or 5 millimeters, a thickness which is evidently unattainable because of the great absorption of light by the glass of such thickness. The grading device permits, therefore, a higher resolving power than a train of prisms.
And that's how they proved that the diffraction gratings were better than the prisms. That's nice.
Did Stone have a comment? I heard his.
Said it was 5 meters.
Yeah, nice, thanks. I was hoping you were gonna come in and wanted to read with your wonderful voice, but I'll keep going. It's cool.
We can't waste Stone on 2 paragraphs, dog.
Is he so low for you guys?
What's that?
Is he super low?
I don't hear him at all.
He is.
You don't hear him at all.
Low.
Okay, cool.
Yeah, hold on. Let me check the bandwidth on the.
Oh,
That's because I got my mic up on top of my head like a.
Okay. All right. Oh, the telescope. If a telescope is focused upon a fixed star, then, and on account of the diffraction at the rim of the objective, the image in the focal plane is a luminous disk, which is larger the smaller the diameter of the objective. The diffraction caused by a circular screen of radius h gives rise to concentric dark rings. The first minimum occurs when the angle of diffraction is such that sine theta equals 0.61 lambda over h times whatever that T-funky cross thing is. Assume that a second star would be distinguished from the first if its central image fell upon the first minimum of the first star. Then to the limiting value of the angle, which the two stars must subtend at the objective if they are to be separated by the telescope, provided with a suitable eyepiece, is theta is greater than 0.61 lambda over h, if lambda be assumed to be the 0.00056 millimeters, and if theta be expressed in the minutes of arc, then theta is greater than 1.17 over h, in which h must be expressed in millimeters. A telescope whose objective is 20 centimeters diameter is then able to resolve the two stars whose angular distance apart is theta equals 0.0117 or 0.7.
Those are minutes and seconds of a degree.
So it's like
these are almost tiniest fractions of a degree that they're talking about. That phi has to be greater than 1.17 arc minutes, which is, a 55th of a degree over h over height. Right? Just absolutely slim. Like they were talking before about how many centimeters over this huge, gigantic measurement,
Yeah, I wanted to say 1.7 prime, and I'm like, that's not right, dude. That's not.
Yeah. Arc second. What did he do? Arc seconds to, or arc minutes to seconds?
117 minutes over there to 7 seconds, yeah.
Jeez Louise, as they say.
Can you scroll back up to the other page real quick? I want to see that footnote.
Absolutely. Oh, yeah. Thank you. I was looking at that and then I forgot about it.
This p is larger in comparison to lambda. Phi substitute for sine phi.
I need to get me a prism.
The inverse of the angle then?
Now they're saying it's so ridiculously small that they wouldn't want to sine function it and obliterate the figure entirely relative to the magnitude of the other figures. So they just, fuck it, it's small. Okay.
Oh, that's what I thought they said.
Gotcha. That's what it sounded like. Okay. For the deduction of the oh yeah, it says right here for the deduction it'd be really small and everything Stone just said is
check this other paper.
It just said Stone's right. That's the third footnote.
All right, here we go. So we got one more here. Just this paragraph.
Well, hold on. Levi found the box of tacos.
I can
Right. The limit of the resolution of the human eye. The above consideration may be applied to the human eye with a single difference that the wavelength lambda of light in the lens of the eye, whose index is 1.4, is 1 to a ratio of 1.5 times smaller than in air. The radius of the pupil takes the place of h. If h is assumed to be 2 millimeters, then the smallest visual angle which two luminous points can subtend if they are able to be resolved by the human eye is phi equals 0.42 arc seconds.
Minutes.
Oh, minutes. Sorry. Thank you. Yep.
Yep. Single
And-
tick for the minute, double tick for
Yep.
the seconds.
Yep. All right. And then the actual limit is about phi equals 1 arc minute. Oh, so this is the real limit, and then this is like the Bertenzes, or what? Or is it just
That's
close
reified
approximation,
math as
general
opposed
average?
to empirical.
Spaghetti. All right, cool. Well, that was not as much information as I thought it was going to be, so I do apologize for that.
Wait, so isn't that so you're saying phi equals 0.42 arc minutes? That is the proper calculated, and then they're just saying, but we say it's 1. Is that what just happened there?
No, this
Yep,
one
pretty much.
No,
When I
isn't
say
the
actual
one
limit, I'm guessing that's based on testing of the human eye, and they say, okay, it's actually 1 arc minute. It's got to be bigger before we see two things as one thing. Like we actually see them turn into one thing sooner. You know what I mean? Because it's 1 arc minute instead of less than half an arc minute.
So I don't see the angle just
thank you.
represented for the telescope diameter instead of like, because it's also for when 1 becomes 2, but then the angle of intercedence as well, or did they only do 1?
Yeah, they're using 2 millimeters, it said. Radius of a pupil.
Dude, prisms must be like the old school G weapon. I mean, we gotta get some prisms.
Yeah, that was what they were originally rocking with.
It
Determining
would
that
be a
light
lot
speed-
cooler if we all had a bunch of prisms.
It'd be a lot cooler.
I feel like that's a very true statement. All right. So what do we have next?
There was the I can't remember the name of that paper. The paper Piezo dropped earlier.
What's up, boys?
Oh,
Look who it is.
Speaking of your boy, dog, what's good? There he is.
Oh,
Yo,
you just pulled the paper
Piezo.
up just in time.
Yo,
Yeah,
it's
you
like
Stop that.
You looking to get popcorned?
I'm not gonna be able to read right this second because I'm still driving in my car, but I'm listening.
I'm trying to pass it off to anyone else, so that doesn't help us all.
nice. Well, this is a 45-page paper, so there'll
Ooh.
definitely be time when you get home.
Yeah, or if you want to wake up in the morning and pick up.
It's really cool that I just timed it so perfectly without even trying.
That to be so helpful or whatever. Or not.
He just released it too, like a couple days ago.
Oh, dang, that's crazy. Awesome.
Nice. Shout out to your boy. All right, so the
Does
fundamentals.
this make us cutting edge?
Only if we had
Absolutely.
prisms. So
Cutting
yeah.
edge ether tech.
Cutting edge ether review or whatever.
Yeah. We're gonna rename this video.
Yeah. Yeah, sorry about the optics thing. I thought there was way more gravy in there because the way that dude made it sound in this paper, it was like Einstein had to get all his information from this, and it was like that was pretty.
It was interesting. I don't regret reading it, that's for sure.
It's based off the human eye, bro. That's important to know.
Yeah.
Yeah. Thought there was going to be more, though. All right, so
Shane, were you able to incorporate the magneto compression into the moon thing?
Perfectly, I nailed it. Let's go.
Sweet.
Nice. All right, the mechanical origin of the electrostatic force, the nature of the electric field, radio waves, and light, a solution to the wave-particle duality, the propagation of light in channels, helping Millikan explain the photoelectric effect. Dude, I always thought Millikan could use a hand explaining that. So that's cool that he's offering to help.
Nice.
All right, so this is Onel the newspaper. Abstract. This work is a further development of the theory that explains electrostatic attractions and repulsions by the molecular vibration of objects acting on one another through a liquid ether that fills the vacuum and the interatomic spaces of substances. The physical origin of the electric field is that of a to and fro motion from the ether. The 2,000-year-old problem of a mechanical explanation of the laws of electrostatics is answered by the behavior of coupled oscillators. Light and the ratio of waves are shown to be longitudinal waves consisting of to and fro motions of ether along the direction of wave propagation, which makes them essentially electric waves. The 100-year-old problems of the photoelectric effect and the wave-particle duality are solved by uncovering the direct link between voltage and frequency of vibration by a new interpretation of de Broglie equation and by advancing a new theory of light propagation in channels. 1 second, gonna grab some water. Gonna grab some water. This work claims to solve the 2,000-year-old problem of giving a mechanical explanation of the electrostatic force. It is part of a broader project aimed at finding the mechanical explanation for all interactions at a distance, gravitational, electrostatic, magnetic, as well as the propagation of light through the ether as longitudinal waves, or as a longitudinal wave. Explaining electrostatics mechanically has been known historically the most challenging of all interactions at a distance. Recognized as such by the scientists of the 19th century, who were fully immersed in the experimentation and mathematical representation of the phenomenon of electrostatics and magnetism, one of whom was William Thomson, aka Lord Kelvin. Shout out to your boy. Although he is remembered today as the inventor of the scale of absolute temperature, William Thomson's main line of work was in the field of electromagnetism. He contributed to the successful transmission of electrical signals through the first transatlantic cable that linked Europe and America. William Thomson was a contemporary with the likes of Stokes, Joule, Maxwell, and Heaviside, whose works he had followed and understood, as well as the works of Faraday and Green, who preceded him. He invented important instruments for the measurements of electrical quantities and was involved in the setting up of electrical units of measure used today in electricity and magnetism. His positioning in the midst of the scientific activities, both experimental and theoretical, that took place in the second half of the 19th century, are contributed to the development of electricity and magnetism, makes his opinions and thoughts extremely important. Relevant to the present work is William Thomson's recognition in his 1889 address, Ether, Electricity, and Ponderable Matter, which is available on ethercosmology.com for free, of the necessity of the mechanical and electrical theory and magnetic interactions. We have a quote here from the reference from Thomson. The demand for something like a mechanical explanation for the electrical phenomenon is not new, but is growing in intensity every year. Remarkably, a remarkable thought of William Thomson is his hopelessness that he will ever be able to find a mechanical explanation for the electrostatic phenomenon. Quote here from Thomson again. Now with reference to the electrostatic effect, the hopeless. I must not say hopeless, that is too large a word. We are never without hope, since I was going to use another word, despair. Well, I feel it desperately difficult. I feel the probability of me seeing the solution of it is hopeless. Dang. It's unfortunate. He had a way with words, huh?
Debbie Downer.
And again, we have another quote from him where he just starts singing Adam's song from Blink-182. The illusions or attempted explanation. Oh, just kidding. I'll read what he says. I have absolutely not ignored I have absolutely not ignored because I have spoken of it in 2 or 3 times, but I have left out the cold. But I have left it out in the cold. The electrostatic part, the thing we knew first. Our first love was electrostatic. He broke up with it, dude. It sucks. Yeah, can you play that while I read it? That is absolutely left out in the cold. We do not touch it. Oh, dang. We do not get near explaining the mutual force between electrified bodies in any of these illustrations or attempted explanations.
But we thought we'd write a big long book anyway.
But we thought we'd tell you about it anyway. The illustrations or attempted explanations William was referring to in the quote above were mostly related to the magnetic effect and the electric current, for which the mechanical explanation has been represented in a series of works titled Fundaments of the Theory of Ether. And although the knowledge of fluid mechanics was relatively well developed in William Thomson's time, the fact that the nature of the electric current was not well understood prevented everyone from observing that the electric current in nature of the surface of waves along a conductor would generate the required circulation of the ether surrounding the conductor, which ether circulation many thought constituted the magnetic field and the current produced. Perhaps the closest to the theory came the description of propagation of electricity in a wire was similar to the propagation of sound through an elastic body, or by the propagation of motion throughout a series of ivory balls. In connection with the magnetic field, with the magnetic effect of the electric current, it is interesting to mention here William Thomson's strong belief that the interior of the current-carrying solenoid, the ether rotates continuously or through a definite angle. He could not tell of which of these two actually occurred. Yeah, we'll definitely have to come back to some solenoids later, because there was that one that was done that what's his name? Bennett was telling us about. That was a huge ether proof. So let's see. I must note before we look at the quote that I considered quite unreasonable, William Thomson's assumptions that the ether had rotational rigidity and that the electric fluid drags the ether. Imagine this: figure 2 or 3 to be the section of an ordinary helix or solenoid with the solid copper core. Imagine a continuous electric current in 2 or an alternating current in 3. So we got your alternating current and we got your continuous current there of electricity sent through the solenoid, shown in section by the outer circle. Whatever the current of electricity may be, I believe this is a reality. It does not pull the ether around within the solenoid. I do not think this is a dream of electromagnetic theory. Difficult as the idea is, I believe it to be a reality. Whether ether is, we move through it, the earth moves through it. So, difficult as the idea is, I believe it to be a reality. Whether ether is, we move through it, the earth moves through it. Okay. Oh, whatever the ether is, sorry. My bad. Somehow or other, however it is, the ether is pulled around. The ether does get a turning motion in the interior of a solenoid. Somehow or other, the electric current through the surrounding wire does give a turning motion to the ether in our supposed copper core, and in the air between it and the wire through which the current is flowing. And this is like a continuation of like quotes or whatever. And now, instead of alternating current through the helix, a constant current through it, or take a constant current through it. What can it do? One thing or the other it does, either a constant current or a constant current through this helix drags the ether around round inside, or it drags it round to a certain angle proportionate to the strength of the electric current and brings it to a static equilibrium so turned. It does not, or it does either one or the other of these things.
Hmm.
I will end this rather historically scented introduction with the prophecy William Thomson made at the end of 1889 in his address on the topic of the mechanical theory of electricity and magnetism. And with my comment that presents work, or the present work, might fulfill his prophecy. And then he gives a prophecy here. Jesus. All right. Popcorn?
Sure, I'll take it.
Oh, thank God.
And here I am afraid I must end by saying that the difficulties are so great in the way of forming anything like a comprehensive theory that we cannot even imagine a finger post pointing to a way that can lead us toward the explanation. That is not putting it too strongly. I only say we cannot now imagine it. But this time next year, this time 10 years, this time 100 years, probably it will be just as easy as we think it is to understand that glass of water, which seems now so plain and simple. I cannot doubt but that these things, which now seem to us so mysterious, will be no mysteries at all. That the scales will fall from our eyes, that we shall learn to look on things in a different way. When that which is now a difficulty will be the only common sense and intelligible way of looking at the subject. I ask you to pardon me for leading you up to so impotent a conclusion that we really know nothing below the surface of this grand subject, which constitutes the province of the Institution of Electrical Engineers. In this year, the year 2024, this time 100 years, William Thomson prophesied about in his 1889 address quoted above, and is the present work, albeit 35 years later than prophesied, going to be the one showing how to look on things in a different way, quote unquote. Quote, the only common sense and intelligible way of looking at the subject, quote, of electrostatics. I can only hope that what follows will, in William Thomson's words, make the scales fall from our eyes, quote unquote. And he's referencing William Thomson. What was that saying? Go back up to the footnote. He was referencing William Thomson, Mathematical and Physical Papers, Volume 3, Cambridge University. So the effluvium and the 2,000-year-old problem of explaining electrostatics mechanically. Have you ever wondered how scientists who observed and wrote about electrical phenomena since Plutarch almost 2,000 years ago have actually attempted to explain what they are seeing? They were all, without exceptions, discussing the effluvium, or emanation, a type of fluid the electrical objects seem to emit in all directions. For how else could the electrical object act on another object at a distance away from it? Of course, this fluid was invisible, but the idea of effluvium was important because it was employed to give a mechanical explanation of the attractions that were observed. Initially, it was believed that the effluvium displaced the air around the charged object, and that the air pressure imbalance thus created forced any nearby objects toward the charged object. Later, when the same interactions were observed by Robert Boyle to take place in vacuum, it became clear that it was not the air but the ether that played a role in the observed interactions, since the ether was believed to remain in space of Torricellian vacuum. Unsurprisingly, the author of the 3 Laws of Mathematics, Isaac Newton, attempted a mechanical explanation of the electrostatic attraction with the help of an elastic fluid emitted by the electrical object. As incredible as it might seem, more than 100 years had to pass between the first scientific investigation of electricity by Gilbert in 1600 and that of electrostatic repulsion by Gray and Dufay in 1733. Thus, it can be said that proper study of electrostatic repulsion has been overlooked for about 16 centuries. If we count since the time of Plutarch in the next year, 100 AD, when people attempted their first explanations of the electrostatic force, Benjamin Franklin, in spite of his extensive researches in electricity, was perplexed, quote unquote, when he learned that electrostatic repulsion existed between two bodies resonantly electrified. Electrostatic repulsion was difficult to explain in a science whose name, electricity, entered the English language as a, quote, power to attract straws or light bodies, unquote. The science of electricity has complicated development. And one of the reasons for this complication was Dufay's introduction of the idea of existence of two kinds of electricity to explain electrostatic repulsion. It can be said that Dufay's introduction of the idea of existence of two kinds of electricity almost put an end to the whole effort of finding a mechanical explanation of... and there's a bunch of sources there. Take your screenshot if you wanted to, go do a bunch of insane extra credit work. The electrostatic interactions, because his view implied the two kinds of electricity acted on one another at a distance. To make matters worse, the concept of effluvium seemed to give contradictory explanations in the case of electrostatic repulsion. For how to explain repulsion between two electrical objects if they both emit, and especially if they both absorb effluvium. Effluvium is nevertheless an important concept to return to and reconsider because it is a healthy scientific concept. Well said. And that, it's in so many, I don't know, you could try and make arguments about a bunch of different paradigms, but we have that, and then we have atomism. And I would say it's, objectively more healthy when you don't have to have paradoxical claims to use it. But anyways, being derived from a healthy and legitimate way of scientific reasoning, something that the experiments of the past worked so much with in their effort to find a mechanical explanation of electrostatic interactions. And effluvium is relevant because it naturally led to the development of the theory advanced in this work, which theory, however, makes no use of effluvium at all. Wait, which theory, however? How is this possible? Firstly, effluvium is related to the fact that electrostatic force is a short-range force. Unlike the gravitational force, which acts through the vast distances of the interplanetary space, so although both forces act through the ether, they are not similar because they do not act through the same mechanism. The gravitational force was identified in citation II9 as a buoyancy force in the ether. The ether pressure gradient necessary for its action was being produced by the total radiation emitted by a star or planet. The short-range feature of the electrostatic force is very well captured in the concept of effluvium, because the effluvium, as something emitted by the charged object, cannot be expected to travel too far through the ether from the object that emitted it. However, it is not reasonable to admit that the charged object emits effluvium continuously, because this would mean that a charged object is an infinite store of effluvium. It follows then that the effluvium emitted by a charged object must return back to the charged object that emitted it, which is what some investigators in the past actually believed had occurred. And if the effluvium is emitted, then returns back, then is emitted again, then it returns back again, and so on, we have a to and fro motion of effluvium that originates at the charged object. If that is the case, then there is no need for an effluvium at all, since the same function can be assigned to the ether surrounding a charged object. Taking a charged object as an object in molecular vibration immersed in ether, it can be seen that the ether will be pushed to and fro by the charged object, and this to and fro motion will act on another object placed at a distance. Thus, what we call an object with electric charge is in fact an object charged with energy of vibration. This naturally leads to the conclusion that what we call the electric field surrounding a charged object is in fact a to and fro motion of the ether produced by the vibrations of that object. We have seen in citation II10 that the attractions and repulsions take place between vibrating objects immersed in a liquid, and we will see later how the laws of electrostatics can be explained by the coupling of the vibrating objects acting on one another through the ether. The origin of gravitation and fundaments of a theory of ether, part 2. Section 3. The experimental background of the laws of electrostatics, how the electric charges were invented, a digression into the atomic structure. So, what exactly are the electrostatic phenomena that any theory of electrostatics should be able to explain? The list of 6 electrostatic phenomena below in citation III1 is the most comprehensive due to the inclusion of the last item, not commonly mentioned in the modern textbooks of physics. Attraction between...
Sorry,
attraction...
grabbing his gravitational paper.
Cool.
Those are Roman
good.
numerals 1 through 6.
So I'm going to say I because I wanted to. Attraction between a body positively... Huh?
Said ay.
It's an old expression in my family.
So 1, attraction between a body positively charged and 1 negatively charged. Attraction between a body positively charged and 1 uncharged. Attraction between a body negatively charged and 1 uncharged. Repulsion between 2 positively charged bodies. Repulsion between 2 negatively charged bodies. And finally, attraction that may occur between 2 bodies that have charges of the same sign, quote unquote, but with the charge on one of them relatively weak. Well, there's really not quotes there, but I just sign is an interesting way to phrase it. Any case, let us recall briefly how the artificial concepts of electric charge, positive and negative, quote, quote, have been invented. It is best to start with Benjamin Franklin's theory that explained the charging of a glass rod by rubbing it with a piece of silk. He considered that through rubbing, the glass rod gained some electric fluid from this piece of silk, which piece of silk was therefore considered to have lost some of its own electric fluid. Since glass contained the electric fluid, it contained more than the normal quantity of electric fluid it had before rubbing, and because of this excess of electric fluid, it was called by Franklin, quote, charge, unquote, quote, positive. So, yeah, positive charge, quote unquote. The silk, since it lost some of its electric fluid, had a deficit of electric fluid and was called charge negative. There were no 2 types of electricity at this stage of development of the electrical science. There was only the electric fluid that was transferred from one object through rubbing in a way very similar to water that can be transferred from one container to another. Charge meant simply load. A load of electric fluid in the case of a glass, and by extension, a deficit of electric fluid in the case of silk. The topic of electric fluid was discussed in a previous work of the series where it was assigned by the name electrogen, a place in the periodic table of the chemical elements, the chemical symbol E, and considered to have, quote, electric or no, quote, electric charge of its own in the sense that electric charge is understood today. In fact, the quote below in citation III shows that the electric fluid was considered an element also by Franklin himself. And that's from citation III4. So the idea of the electric fluid as a distinct chemical element should not appear so unusual to anyone today. This observation, so quote, this is again, I think, from citation III4, which is Benjamin Franklin, Experiments and Observations on Electricity. This observation suggested to Franklin that the same hypothesis that, unknown to him, had been propounded a few months previously by Watson, namely that electricity is an element present in a certain proportion in all matter in its normal condition. It is worth noting here Watson's hypothesis mentioned in the above quote of citation III5, according to which that one would be Edmund Taylor Whittaker, A History on the Theories of Ether and Electricity. Wait, is that the book I have? No. Okay. The electric fluid existed and was the origin of electric...
It's in the library.
It is? Nice. I have a physical book of a similar title as well.
Oh, okay.
I have shewn that electricity is the effect of a very subtle and elastic fluid occupying all bodies, and that where everywhere in its natural state, it is of the same degree of density, and that glass and other bodies have the power by certain known operations of taking this fluid from one body and conveying it to another. in a quantity sufficient to be obvious to all our senses, and that, under certain circumstances, it was possible to render the electricity in some bodies more rare than it naturally is, and by communicating this to other bodies to give them an additional quantity and make their electricity more dense. Another stage in the development of the theory was due to Dufay's artificial invention of two types of electrical charge, vitreous and resinous. Made with the purpose of explaining the electrostatic repulsion that he was first to study, it must be stated here that although Dufay claimed to explain the electrical phenomena he was observing by inventing two types of electric charge, his invention explained, in fact, nothing. The words vitreous and resinous were chosen by Dufay because glass, vitra in Latin, and sealing wax, which is made from resin, amber, belonging to the same class of materials. In very simple experiments, glass repelled glass, wax repelled wax, whereas glass and wax attracted one another after being rubbed with certain materials.
You skipped a little on there.
Oh, did I?
Yeah. Were the main materials employed in rubbing and obtaining electrical attractions and repulsion?
Oh, are you trying to get popcorned?
That was a yes.
Sure.
You just outed
You wanna
yourself
read for
as
a bit?
being as
It
being
wasn't a
available
no,
to
so
read.
yeah.
I wasn't trying to take it over from you. I was just.
No, you were.
Well,
It's fine.
I'd be happy to popcorn it to you if you want to.
Okay. I'll pick up from there. Yeah, amber belonging to the same class of materials were the main materials employed in rubbing and obtaining electrical attractions and repulsions. In very similar experiments, glass repelled glass, wax repelled wax, whereas glass and wax attracted one another after being rubbed with certain materials. By extension, then, all objects that repelled glass after being rubbed with other materials were considered to have glass-like or vitreous electricity. The same procedure was applied to determine the wax-like or resinous electricity of other rubbed objects. However, this procedure was actually inconsistent because glass can be made to attract glass if the two are rubbed with different materials. Wax can be made to attract wax if the two are rubbed with different materials. And glass can be made to repel wax if the two are rubbed with certain different materials. Even rubbing two identical materials, such as two glass plates, will result in different electricities on each plate, and the same is true for two pieces of resin. It can be seen that Dufay's introduction of two types of electricity was questionable from the very beginning, because all that happened through rubbing was to create objects that attracted or repelled one another, and this is all that a theory of electrostatics was, and still is, supposed to explain. The invention of two types of electricity does not solve the problem of explaining why and how objects repel and attract. In fact, it can be seen at point 6 in the list of electrostatic phenomena, shown at the beginning of this section, that there are gradations even among electricities of the same type, in that stronger and weaker electricities of the same type can actually attract one another, defeating the very purpose for which two types of electricity were invented. In the third and last stage of the development of the theory of electricity, Franklin's conception of positive charge or load due to excess of electric fluid in glass was combined with Dufay's conception of vitreous types of electricity for the same material, resulting in the invention of positive charge as a distinct physical entity, which is elevated to the status of a fundamental irreducible property of matter in today's physics. The same happened with the invention of the negative charge. The combination of Franklin's negative charge due to deficit of electric fluid in wax and Dufay's conception of resinous type of electricity for the same material resulted in the invention of negative charge as a distinct physical entity in use today. The author of this strange mix of ideas was Robert Seymour, who did not base it on any experimental observations, nor could he have. He put it forward as a personal thought. It was Augustin Coulomb who, for some reason, preferred it, promoted it, and tried to bring, unsuccessfully, experimental arguments in its favor. Is that Augustin Coulomb?
His name was Augustine? That's kind of a letdown, isn't it?
All right. The strangeness of the coexistence of two opposite types of charges in the same object, which are supposed to attract and cancel one another when the object is neutral, is felt by many people when they learn about it for the first time. These mutually canceling charges are then supposed to be separable by external forces and be transferred further on other objects through contact, We are asked to believe that they exist inside the atom of an element, attracting one another but not annihilating each other, creating tremendous problems for the understanding of the atom, but nevertheless forming the basis for the current model of atomic structure, in which a positive central part, the atomic nucleus, is surrounded by a negative cloud, the electronic shells, inexplicably coexisting as fundamental and separate physical entities, leading to absurdities such as the planetary theory of the atom, in which the electron accelerates in its circular motion around the nucleus without emitting radiation, although it's expected to, which absurdities are simply dismissed through Bohr postulates, proclaiming that the physics happening within the atom is different from the physics happening without it, and thus creating a so-called class of quantum phenomena whose common property is to be weird and incomprehensible. Needless to
Dude.
say that I find the situation unacceptable.
Wow.
Shout out to you. Like, I'm not sure which part to highlight. Is it just
All of it, dude.
Yeah.
Is it the whole thing? Okay.
I think that one just needs to go straight into Sono to make a song.
Man, this
Actually, this is a whole Twitter post.
Yeah, that's already. I already copied it. Actually, it's already.
this
on there.
man's making me use my brain right now. It is amazing and ironic to see how some authors in the past describe the relationship between the two types of electricity as being the same as the two elements of common salt, chlorine and sodium, which, when united in certain proportion, produce a neutral salt, whose union is attended not by a destruction of either element, but by a balancing of their chemical activities. This looks like a circular argument, because here the union of chlorine and sodium is used to illustrate two electricities neutralizing each other in a chemically neutral substance, while today's chemistry uses the doctrine of positive and negative electric charges to account precisely for the formation of the sodium chloride salt through ionic bonding. The laws of electrostatics, like charges repel and like charges attract, originally introduced by Dufay for vitreous and resonance types of electricity, were not explained by Dufay. He just found these attractions and repulsions to occur empirically, i.e., through his experimental observations. After Dufay, people were forced to assign all electrical objects to one of these two types, vitreous or resonance, even if, as explained above, the same substance could be made to behave sometimes like a vitreous and sometimes like a resonance one. Moreover, since the mechanisms of these attractions and repulsions were not explained by Dufay then, they remain unexplained now in the modern electrical science. No fundamental reason can be given why positive or vitreous charge should repel another positive or vitreous charge. In an exceptionally well-written textbook on electricity and magnetism, published at the beginning of the last century, these issues have been correctly highlighted and mentioned to the students of electrostatics, showing that scientists and researchers who were aware of these problems until very late in the development of this science. So careful were the authors with the terminology that instead of two types of electricity, they employed the term two types of electrification. Coming towards modern era, we observe the fallacy of positive and negative electricity perpetuated and enhanced. J.J. Thomson, the discoverer of the electron, in spite of being well aware of the way in which and the reason for which the concepts of positive and negative electricity were developed, namely to explain electrostatic attractions and repulsions, makes the mistake of assigning to his corpuscle an absolute negative charge, and then tries to explain the action at a distance between electric charges by Faraday's lines of force in the ether. J.J. Thomson's explanation fails, however, because he cannot explain how an electric charge produces these lines of force, why the lines have different directions for the two types of charge, why the lines are elastic and behave like rubber bands, and, most importantly, because J.J. Thomson makes the fatal mistake of assigning mass to the ether itself and claiming that the lines of force drag the ether and that this causes the mass of charges and of all matter.
It's looking like another whole entire highlight to me. Jeez.
The drag is not well explained, nor possible, as it is not clear why it occurs only when the charge accelerates, and not also when the charge moves with uniform velocity.
Dude,
Moreover,
dude,
moreover,
the cyclotron, bro.
He said, "Damn."
Okay,
Mo-
sorry.
Moreover, in my opinion, assigning mass to the ether defeats one of the purposes the ether exists for, which is to explain the origin of mass of objects by a hydrodynamical effect due to the acceleration of objects in it. The ether does not have intrinsic mass. It is the cause and the origin of mass. But a definite volume of ether accelerating through ether can display inertia. So this volume of ether acquires mass only when in and because of this state of accelerated motion through the ether. Returning to electrostatics, to state again what has been noted once above, what happens in electrostatic phenomena at the fundamental level is that through rubbing, mere contact, or other methods, objects are created that attract and repel one another. And this is all that a theory of electrostatics was, and still is, supposed to explain. Since the introduction of two types of electric charges, positive and negative, by Dufay, does not solve the issue of explaining the attractions and repulsions observed in electrostatic phenomena, the present work takes the following approach. Dufay's conjecture for the existence of two types of electricity is dismissed. Only one substance is recognized, Franklin's electric fluid, named in this series of works electrogen. The electrostatic attractions and repulsions between electrical objects are explained by a two-stage process. 1. The quantity of electrogen contained in the objects changes by its transfer through rubbing, contact, influence, or other methods. And 2. This leads to changes in the natural frequency of vibrations of the electrogen in the objects. It can be said that the theory proposed here is a revival and an expansion of a theory contemplated by the scientists of the 19th century, which they called the molecular theory of electricity, or electricity, a mode of movement theory.
Wow.
In the theory, real quick pause. I already knew about this electric fluid. This is like making a lot of sense to me because I read it in that book, which was one of the first books I ever brought to you guys, which was the Whole Art of Conjuring, published in the Library of Congress in like the 1830s. I don't know if y'all remember that.
Nope.
I do remember. You read it.
Yeah.
Live, I think, or some of it.
Yeah. So, anyways, in the theory proposed in this work, the concept of charge is derived from Franklin's original idea of deficiency or excess, i.e., less or more load, of electrogen in an object. As stated by Watson in the earlier quote, the electrical phenomena themselves are caused by the electric fluid. So the term electrogen applied to Franklin's electric fluid is extremely appropriate since it means producer of electrical phenomena, the naming being similar to that used for other elements of the periodic table, such as hydrogen, that means water producer, oxygen, that means acid producer, nitrogen, that means nitrate producer, ASO, and so on. Moreover, electrogen causes electrical phenomena through its vibration. So electric charge will imply electrogen causing attractions and repulsions by its state of vibration, as only by vibrations can the ether be pushed to and fro, and a charged object act on another at a distance. And since the electrogen is just one of the chemical elements of the periodic table, the other elements of the periodic table may also be brought in a state of vibration and cause a to and fro motion of the ether around them to act on another element situated at a distance. In other words, a charged object will mean an object that has electrogen in vibration in a normal quantity, in excess or deficit, and in the case of the complete absence of electrogen in an object, charge will imply that it is other chemical elements in the object that vibrate and act on the ether with periodic motion. The problem of attractions and repulsions between charged objects becomes thus one of interactions between objects in molecular vibration made up of different chemical elements in different proportions, including the chemical element electrogen, E. Electrogen exists in all substances, being the glue that bonds the atoms of elements together chemically in molecules, or physically in liquids and solids, and covers the isolated atom of an element like a film of a certain thickness. Since the word atom was mentioned above, a little digression on this topic is in order here. In the theory advanced in this work, what is currently called atom of an element is considered to be in reality made up of two chemical elements. The nucleus is the real atom of the chemical element, but without a positive charge. The nucleus behaves as if it was charged positively, i.e., it produces attractions and repulsions, only when brought into a state of vibration. The electronic shells surrounding the nucleus are, in fact, a layer of electrogen covering the nucleus. There is no attraction between the two, as it is assumed in the current theory of atomic structure, where the positive nucleus attracts the negative electrons. The electrogen simply covers the nucleus and clings to it due to external ether pressure exerted on the positive nucleus. It is not the aim of this work to advance a new theory of atomic structure, but as mentioned in reference 315, the atomic model based on Bohr's ad hoc postulates is highly problematic, inconsistent, and relies on the fundamental electrostatic structure derived from Dufay-Seymour-Coulomb's unnecessary doctrine of the presence of positive and negative electric charges. The alternative to this doctrine is the two chemical elements theory of atom outlined above, which is more promising, since waves of electrogen on the surface of the atom, or just surface waves on the atom itself, can lead to explaining the atomic line emission spectra in a mechanical way, which was the original approach scientists took when studying atomic spectra during the acoustic period, mentioned in reference 315. Noteworthy in this respect are the recent works 316, 17, and 18 that start from de Broglie's original proposal of two-dimensional stationary electronic wave in an atom and take it to its logical and natural three-dimensional representation, leading to atomic vibration modes with different frequencies, while the shape of the vibrating atom in spherical geometry represents strikingly the atomic orbitals obtained by quantum mechanics calculations. Can you go back up for just a second? I'm going to read that again.
Yeah, I've heard that before.
Yeah, noteworthy in this respect in the recent works that start from de Broglie's original proposal of two-dimensional stationary electronic waves in an atom and take it to its logical and natural three-dimensional representation. So there's that picture, de Broglie's two-dimensional in the middle, and then the three-dimensional over there, leading to atomic vibration modes with different frequencies, while the shape of the vibrating atom in spherical geometry resembles strikingly the atomic orbitals obtained by quantum mechanics. Oh, yeah. If you've ever seen like the SPDF orbital blob-looking things, that's what he's talking about. Okay, got it.
Never seen it, but electron cloud?
Kinda, yeah.
Valence levels.
Yeah, the energy states.
Oh, bet. Yeah, I got you. One of these, 1 second, for the lads at home.
Yeah, man.
Second's the wrong one.
Yeah.
GPS.
Quantized electron energy states.
Mm-hmm.
Yeah, this right here, the old valence
That's the
electron.
one.
Yeah.
Yeah, well,
okay.
they have shapes though. Like there's like blob shapes that when they do the energy imaging, they have like they can quote unquote see what it looks like.
Right, like this on the right.
Not exactly like that. Yeah. We'll look at it later.
Cool.
These atomic vibrations brought about when the atoms of an element are excited through sparks, arcs, or electrical discharges in low-pressure glass tubes cause the emission of radiations with frequencies corresponding to their respective vibration modes, say FM, F sub M, and F sub N, in contradiction with Bohr's postulate that the emission of radiation has the frequency F sub Mn and takes place when one electron jumps between two stationary states, corresponding to the atomic orbitals of energy E sub m and E sub n, such that H F sub mn equals E sub m minus E sub n. What many modern textbooks on the quantum theory of atom fail to make explicit and clear is that all the frequencies F sub mn and mn are observed in the emission spectrum of an element and are connected through the simple relationship discovered by Walther Ritz and called Rydberg-Ritz combination principle. F sub mn equals F sub m minus F sub n and plus this, so there's the minus and the plus, from which it can be seen that, yeah, okay. As such, the whole line emission spectrum of an element can be considered as a mixture of radiations emitted by the excited atoms of the gas vibrating in different modes and frequencies, and in which higher frequencies are obtained through the principle of heterodyning proposed by Juliana Mortensen.
So can we hold just for a second and scroll back up to the 2D, 3D? Yeah. Okay, so what we're actually looking at on the far right is a set of concentric spheres cut open in cross-section.
Mm-hmm. Yep.
Okay, so
Cut
that
a
is
cube sphere
supposed
in
to
half.
represent all, with respect to quantum mathematics, those spheres represent all paths of the electrons on each of those energetic level states, distances away from the nucleus, right?
And they
Okay,
jump
so we
between
notice-
levels.
Right, as they increase or decrease in energy state, and you create ionization and from this mechanism, mathematically speaking. But you see, this is what they talk about at the quantum level, that each one of those spheres represents the path of a handful maybe of electrons occupying all of that space around the nucleus, such that every possible point around that sphere is being covered by the passage, the orbit, so to speak, of those finite number of electrons, right?
Mm-hmm.
Okay, great. Now, let's go to the astronomical scale. The solar ecliptic, for example. That our solar system, quote, has all the planets, except for one that's not really a planet, because we got to argue about that for decades, all of them seem to be existing on the same ecliptic plane. 2D analysis, if you know what I mean. 2D effect of the model at the astronomical scale. Why do we have a solar ecliptic plane? It doesn't match physics in any way they describe it like this. We're seeing at the quantum level where we should have planetary ecliptics around the sun at all angles, shouldn't we? Because the probabilities exist.
Is it because they took the
In
spherical
fact,
sky?
the probabilities exist even more so than this diagram, because we have only technically one electron per energy state in the solar system, so to speak, right? We've only got one thing going around the around the sun rather, at Earth's orbital radius. Again, one thing around, it's just us at our radius away from the sun. It's just Mars at that radius away from the sun. And we are all mysteriously on the same ecliptic plane. Nothing like what we represent here at the quantum level, where these things are all flying around and producing essentially a sphere as a snapshot in time. I just thought I find that most conspicuous. And I don't hear a lot of people talking about that. Just thought I'd point it out.
Hey, why is the solar system flat? Yeah.
You got it. When every other analysis they do in 3D of things orbiting things, it looks like this 3D cross-section, 316.
Yep.
Right?
Yeah.
It's just, we don't talk about that.
Yeah.
That's a good point.
Maybe they
You
took
think-
a flat ground and a spherical sky and flipped them.
Do you think they would, like, to steelman their position, do you think it would be because they don't account for gravity on that scale? So the way that it would work itself out on the macro scale would be these spheres are attracted to their point center mass, so it just like makes a nice clean disk or whatever. But because that's not really what they're dealing with on this little scale, it just maps out differently.
I think only one of the two scales can be true at all scales.
Yeah, fact.
That if we're going
I
to
agree with that,
agree
yeah.
that this quantum model is valid, then the astronomical one cannot be. And if we're going to agree that the astronomical model is the way, the truth, and the life, then this quantum model is bunk. Either way, they're snafuing themselves just out of scale. That's kind of what I'm trying to point out. Anyways, go right ahead, guys.
No, well said. Thank you for bringing it back in. 100%. All right. Pizia, do you want to continue? Or you can pass
Sure,
the mic if you want.
Just
You're
to the
free
next
popcorn.
page.
It's okay. Yeah, we just finished this one.
Yeah. Oh yeah. Shout out to this lady real quick, Juliana Mortensen or whatever. She did this paper here. She points out the quantum flaw where the E equals h nu is linked to a 1 second interval. So it like makes the wrong predictions all the time, and it's just kinematics. It's a pretty cool paper. This lady rocks. All right, go ahead.
Another notable consequence of the theory proposed here is that, starting from the complete line spectrum of an atom, it is possible to predict the real shape of the atom of an element, since it is the real structure whose vibration produces the radiation, and the possible shape or shapes of a vibrating structure can be determined from its normal vibration modes. What? Huh. On the next 3 pages, I have tried to show through diagrams the great leap in our understanding of the atom brought about by the atomic theory proposed in this work that improves upon 3, 16, 17, and 18 through the use of real spherical surface waves of electrogen covering the atomic nucleus that act on the ether mechanically to produce radiation, over the currently accepted model of the atom based on quantum mechanical calculations that use the Schrodinger's probability wave equation for a negatively charged electron around a positively charged proton, and presently taught to high school and to college students. See this? This is what it looks like. That what we were talking about earlier. This is
Gotcha.
this is a 1s 2s 2p orbital diagram of an atom.
This is mathematical porn.
A quantum mechanical atom. So in the 1920s, Werner Heisenberg changed the model of the atom, which had
Just fucking
electrons,
math. I'm sorry.
which had electrons in orbits like planets in a solar system. His uncertainty principle says that we cannot know the exact position and velocity of anything at a given moment. Instead of specific orbits, his new version of the atom has regions around the nucleus in which there is a high probability of finding an electron, and the shapes of these probability clouds represent what we currently refer to as the electron orbitals.
Sort of like the chances of finding a WMD.
So always 0, and if we ever found it, everything would collapse. So therefore we can't find it, but we know it exists. Is that one of those deals?
Afghanistan has a gigantic probability cloud.
Oh, dude.
The Schrodinger equation for the hydrogen atom can be solved most readily by using spherical coordinates. Nucleus charge plus E at the origin, electron charge minus E at coordinates. Okay, that's there. Okay. Figure 41.
See, there's theta and phi, and in the solar system we only have phi. We don't have theta.
Yeah. Yeah, 3 axes versus 2. Yeah.
Well, they throw in just a tiny bit of phi every now and then, but only on the rotational axis. Like 3 or 4 different. I guess really they go past phi, right? They start getting into a bunch of extra variables because they're like, oh, we got to have this wobble, and this wobble.
Wobble.
41.9 3-dimensional probability distribution functions. Whatever that trident symbol is, squared.
Psi.
Capital Phi squared for the symmetric for the spherically symmetric.
Psi.
Oh, psi.
PSI.
Oh, psi. Okay. Psi squared. Absolute value of psi squared for the spherically symmetric 1s, 2s, and 3s hydrogen atom wave functions. And then cross sections. Okay. We get it. This is what it looks like. Okay, cool.
That's where we think the electrons are hiding.
Yeah. Okay.
Definitely this time.
If we could measure them, this is where we would find them, and this would be the distribution density of where we would find them, like probabilistically. Okay. Cool.
Donut.
Only the diagrams have been reproduced from 318. The captions and comments are added to correspond to the theory proposed here. Okay. Oh, okay. Electrogen vibration with no nodal lines resemble the s orbital. The atom expands and contracts radially. Okay. Electrogen vibrations with one nodal line represent the p orbitals. The atom expands and contracts along 3 perpendicular directions. Okay. Detail of the electrogen vibration resembling one of the p orbitals. Points of greatest vibration amplitude up there in the top and bottom, and then maximum probability of finding it. So like when they're doing this energy imaging, right, they're measuring the energy, like the radiation giving off. He's basically saying that these there's like this mechanical interaction between the electrogen and the ether due to the vibration of the molecules at its resonant frequency or whatever, and it's giving off this radiation energy in a specific shape that corresponds to its vibration frequency and direction, and it looks like what they map out on the energy reading. So like they're
just looking at the spray.
Right, they're looking at the spray that comes off of it, and they're assuming that, oh look, we're measuring a probability distribution of a bunch of electrons. I guess they think it's like I guess they think that the electrons are moving so fast that when they take this snapshot, it's actually like a long exposure because of the, like, if you were to compare it relative to the electron speeds, it's basically that tiny time window that they snap, it's actually like a long exposure for the electrons. So they're seeing like, even though there's only like, you know, a few electrons, you see a million little points because, yeah, it was moving the whole time. I don't know. Anyway, chemistry does not describe the entire vibration of,
Back up there.
Oh, my bad.
Chemistry does not describe the entire vibration in space, only the location of maximum probability of finding an electron. It corresponds to the points of greatest vibration amplitude. Okay, here's the next chart. Detail of the electrogen vibrations resembling one of the d orbitals. The atom expands and contracts along one direction and in a plane perpendicular to that direction. Okay. Yeah, because I learned all these orbital diagrams in chemistry. So.
Or it's diffraction within the instrument. Who knows?
Could be one or the other.
Summary of the atomic vibrations showing the electrogen displacements in white and the nodal lines in red. That's on the left picture. And then the right picture is the summary of the atomic orbitals showing the location. Yeah, so like the right picture is the quantum mechanics orbital diagram theory, and the left is like him saying, here's what these atoms are shaped like and are vibrating like to produce this. Oh, okay. I see what you're doing. I see where he's getting at. The nodal lines. What are the nodal lines?
Yeah, see, I missed that part because he just said casually dropped it, and I don't think he.
You guys are not by nodal lines or what?
Touched it up. Yeah, enlighten.
Is that like the lines at which the ether is like interacting maximally with the electrogen and like the tension points or something? I don't know. The new theory.
Yeah, well, that makes sense.
Explaining the laws of electrostatics by molecular vibration. Returning to the problem of the laws of electrostatics, we have seen in 4.1 that for objects of the same size and vibrating with the same frequency, attractions or repulsions occur between them depending on the vibrations being in opposite phase or being in the same phase, respectively. And this tells us that the way in which an object vibrates with respect to another is fundamental for determining their mutual electrostatic behavior. The figures below are reproduced from page 13 of reference 4.1. Okay. Oh, look at that quadrupole going on down there in that left diagram. Okay. It is observed that these surfaces called membranes attract one another. The membranes move towards and away from each other, i.e. in opposite directions, and therefore they should be considered as vibrating in opposite phase. Membranes vibrating in opposite phase attract one another, which is consistent with the law of electrostatics, unlike charges attract. And then on the right side, it's observed that these surfaces, called membranes, repel one another. Both membranes vibrate to the right and to the left in the same time, i.e., in the same directions, and therefore they should be considered as vibrating with the same phase. Membranes vibrating in the same phase repel one another, which is consistent with the law of electrostatics, like charges repel.
Any comments on the diagrams? Or?
I'm confused a little bit simply because, like, if it's going back and forth, it's starting moving inward and then going outward, or if it's starting going outward and moving inward, like, it's just like two different points in time. Like, it would technically be, I feel like they'd have to be, like, both arrows would have to be to the right, or both arrows to the left would be one polarity, and then arrows flipped would be the other polarity, because he has the arrows flipped in both cases. It's odd the way he's explaining it to me. Towards, he says they vibrate towards and away, and then he says that they vibrate to the right and to the left in the same time. Okay, well, that makes sense. Like, the way the words are describing it makes sense, but I feel like he has the arrows drawn wrong. I don't know.
He does.
Yeah, the right arrow. Yeah, okay. Because if you look at the picture, like the picture,
fourth arrow should point left.
Yeah. The fourth arrow should point left because it has the membrane flexing to the left. Yeah, okay. So he just flipped.
But they're suggesting repulsion. So I don't know, man. There's some kind of inertial assignment going on here that I don't think is very kosher.
Yeah, the vibrating with the same phase is repelling, whereas vibrating with opposite phase is attracting. I don't know, because no. It might. Well, let's read some further. But like I'm thinking about like the vortex thing, because the way that when the rings push towards each other or away from each other, like when they're moving exclusively opposite, they have attraction. Like they're whirling, like kind of like sucks each other in. Anyways.
Well, I don't know. In other wave theory, we're talking about how those two are deconstructive and additive, summing waves in terms of phase, right?
Mm-hmm.
Destructive and constructive wave addition.
Uh-huh.
What we just saw was contrary to that.
Okay. Repulsions and attractions differ considerably in their probability of occurrence. The former happen within very restrictive conditions, only for similar sizes of vibrating objects, same frequency of vibration, same or close phases of vibration. The latter happen, which would be attraction, in more varied circumstances. Different size of objects, different frequencies, any phases, but the phases must be opposite if sizes and frequencies are the same. So he's basically saying that it's not just the phase, but it's the combination of the size, the frequency, and the phase that can control the repulsion and attraction. So it's like three different variables. We arrive, therefore, at the important conclusion that, statistically speaking, attractions are encountered in more situations than repulsions, a fact which is supported by experience and by the historical fact discussed in Section 2, that electrostatic repulsions were studied long after electrostatic attractions. Attractions can be explained by the different sizes of molecules and the different frequencies of the vibration, leading to attractive forces mediated by the ether. Repulsions were initially discovered to take place between a pair of identical objects, such as two glass rods, rubbed with a pair of other identical materials, such as two pieces of silk, and can be explained by the identical sizes of vibrating molecules whose phases of vibration are initially not correlated, but become correlated through a key mechanism proposed here for the first time. Approaching two energy-charged objects to one another leads to an increasingly stronger coupling through the ether between the vibrating molecules of the two objects, which causes the vibrations of the molecules on the two objects to become interlocked, synchronized, and occur in the same phase, resulting in mechanical forces of repulsion between the two objects. The phenomenon outlined above is called phase synchronization of coupled oscillators and is similar to the ones encountered in coupled macroscopic oscillators, such as the synchronization between two pendulum clocks first observed by Huygens, or the amazing phase synchronization that occurs between two or multiple metronomes coupled by sharing the same support. What? The pictures below are from reference 4.3 sub 2, where it can be seen that metronomes in black, initially oscillating in opposite phases, end up oscillating in the same phase due to the strong coupling between them caused by the transmission of oscillations through their common support, the whiteboard. Dude, I didn't know that.
Yeah, I didn't know that either. That's crazy.
In electrostatic interactions, the two metronomes above represent two molecules on two similarly charged objects. The molecules have similar sizes and the same quantity of electrogen, therefore will vibrate with the same natural frequency. Their approachment causes a strong coupling through the ether that transmits their to and fro motions, and they will end up vibrating in the same phase and therefore end up repelling one another irrespective of their initial phases of oscillation. That is, even if their initial phases of oscillation are opposite. Wow. So they end up syncing up if they're able to achieve like mutual contact or proximity close enough that it enables mutual contact due to the strength of our vibrations.
But once again, that example invokes physical inertia.
Okay. Yeah, well,
That's what I'm driving at.
Isn't he, though, saying, like, that this is, like, the ether, the mutual contact of all the bodies in the ether, that the ether is the source of, like, gravitation, of all these things. So, like, when we talk about inertia, when they represent potential energy or inertia or any of that stuff in their equations, all it is, like, residual energy in the ether.
I'm not even satisfied with their assertion of vibration when on the scope we're looking at spray. Even a short exposure to the film, we're looking at spray, just maybe less spray, and somehow we're supposed to calculate a vibrational frequency of something in the material. I'm not sold.
Yeah, well, I mean, in the common model, in the mainstream model, they have a like resonant. Every object has a resonant frequency, like because the molecules in it are vibrating in the mainstream. I mean, I don't know how they measure that.
There you go again. See, it's reflexive, that mainstream brainwashing, because that thing's got a vibration. Whoa, show me what's vibrating. I don't ever see that in the analysis. I never see a hard figure. I never see what you're pointing to that's vibrating. It's just something that's there and it's doing something, and so it must be vibrating. No, man. What we're really looking at here are lines of force through counter space. This is what they're calling the ether. It's fairly synonymous. I don't know. Let's see where this story ends.
The study of coupled oscillators has been extended to more complex systems such as biological organisms and collectivities of animals or humans, and interesting mathematical models have been developed, of which one example is the Kuramoto model. The theory of two charged objects of similar size repelling each other through phase synchronization of their vibrations due to strong coupling through the ether, and of attractions between objects in any other cases, leads to the reformulation of the electrostatic phenomena listed at the beginning of the previous section in terms of molecular vibrations as follows. 1. Electrostatic formulation. Attraction between a body positively charged and one negatively charged. Molecular version. Attraction between a body with a deficit of electrogen and vibration and one with a surplus of electrogen and vibration. 2. Electrostatic. Attraction between a body positively charged and one uncharged. 2. Molecular. Attraction between a body with a deficit of vibrating electrogen and one with electrogen not vibrating at all. 3. Electrostatic is attraction between a body negatively charged and one uncharged. Other one is attraction with a body of surplus electrogen vibrating and an electrogen not vibrating at all. Repulsion between two positively charged is electrostatic, and then repulsion between two bodies of similar sizes with a deficit of electrogen vibration where the vibrations are in same phase due to phase synchronization through strong coupling through ether. Okay. So it's saying what we call like positive repelling positive, he's saying is two electrogen deficits in vibration that end up phase syncing. And what we call two negative repelling negative is two surplus electrogen vibration that repel due to phase syncing. And then 6, which was kind of one of the cruxes earlier, I'm interested in what 6 is going to say. Attraction that may occur between two bodies that have charges of the same size, but with the charge on one of them relatively weak. He says that the molecular model is attraction that may occur between two bodies with surplus or deficit of electrogen vibration, but with the electrogen vibrations different in frequency and amplitude due to different amounts of electrogen surplus or deficit. But with the
So get up to
vibrations,
box 2 again, because these are the original 6 we were looking at on the left side. These were the
Yeah,
6
yeah,
that
yeah.
when Toby was reading, we're looking at. See,
Right.
but 2B over there, where the electron is, quote, not vibrating at all, is it the body that's not vibrating at all? And if it is, then we're talking about a body that is at 0 Kelvin,
I
right?
think he's saying the
That's the only
electrogen is
time
not
when you got
vibrating.
something that's, well, that's the only time you got matter that's not vibrating, is when it's at absolute 0.
Maybe the nucleus is still
So why is it
vibrating.
box number 2?
Three's the same.
How do you tell?
Right. I don't know. I would have to continue looking at it. Well, okay. It's weird to me thinking about this electrogen fluid. I didn't know it was called electrogen. I just knew electric fluid. Because when they used to make hand crank generators, hand crank alternators with like resinous and vitreous materials, they take like an insulator material and a conductive material, and they layer them and put them on this like rolly pin and like spin it, and then they'd connect like a wire to it, and literally by doing that they would like transmit current. And they thought that by rubbing the two different types of material together, they were basically like squeezing the electric fluid out and causing it to like flow along the wire. And it's like, I mean, I think he's onto something with the positive and negative electricity, right? Like that there's only actually one type, and it can be represented in terms of like, what Tesla said, frequency and vibration being the key to everything. But I don't know how this guy's going to flesh it out fully. So like, kind of just, I need to see the rest of it to know if I think it's retarded or not.
Well,
Well, I'm already there. Go ahead.
Can you scroll down? Yeah. What is this? Interesting clues on the behavior of matter with excess and deficit of electrogen in a state of vibration can be obtained from the study of discharges of electricity through gases at very low pressure. Okay. So when we got, electrical discharges happening through some gases that are like very near vacuum, as can be seen from the picture below, the discharge at the positive metallic electrode starts from the surface of the metal, indicating that vibrations there are produced by matter with deficit of electrogen. While at the negative metallic electrode, there is a space between the metal surface and the discharge, indicating that there the vibrations are produced by the surplus of electrogen on the negative electrode. So, okay. Is that how that works? I've never actually looked at this like closely in an experiment of like
I think we're also looking at the left-hand rule.
the left-hand rule. I only know about the right-hand rule.
Well, exactly. He's from the UK, I'm guessing here. It's all about the excess being at the negative instead of at the positive.
Well, either way,
it's just the inversion.
Whichever way you flip it, my question is like, I've never actually looked at like an arc thing happening in like a low gas system. Does one electrode actually have the electricity coming straight off of it and the other one have it like buffered by a little gap? Is that actually what happens?
It's moving at the speed of light. How can you tell?
Well, I don't know. I mean, when the arc is actively on and you can see it with your eyeballs, like, do you see one diode with the arc touching it and the other diode with like a buffer gap?
I think this just looks like an infected snake.
sort of a slither, yes.
All right. We need to check back on this with like a physical video, like watching this happen, because I want to visibly see this with my eyeballs. All right. Ask him, because I mean, if this is actually, intuition would tell you that the electricity would directly touch both electrodes, right? So if we go watch a video of this happening and one side's touching, the other side has a buffer gap, that's going to be real weird for me. As can be seen from the picture below, the discharge at the positive metallic electrode starts from the surface of the metal, indicating that vibrations there are produced by matter with a deficit of electrogen, while at the negative metallic electrode, there's a space between the metal surface and the discharge, indicating that there the vibrations are produced by the surplus of electrogen on this negative electrode. So you're saying that surplus is like literally the reason the electrical discharge is not touching the metal is there's this invisible electrogen between them.
It could be completely the converse, that we're looking on the negative side being not really negative but 0 volts, positive being very high volts, and that, like I said, when we look at what an electron is in terms of spark gapping, which is really what's going on here, we're playing with high voltage over space and watching the catastrophic failure of this capacitance between the 2 points. We're resolving charge, and that's what's going on when these quote electrons or sparks, arcs form, and where they form. This is why he's noting the difference between that as we approach ground, as in we approach the negative side of this diagram, it could be that we're watching the charge, which is, we're seeing all the black dots going through that tube, but then all of a sudden there's nothing between those and where somehow more electric charge is appearing around the negative but never touching the negative. I take that to mean on its way to the negative, but then ceases to be just before actually physically touching the negative. And again, when we talk about this driving ether over a conduit and whether or not it's got a vortexual motion or not, like remember the arrows on the circles we were looking at with the cross-sectional pair way back 4 pages ago?
Yeah.
This is exactly the same thing we're looking at in cross-section, that we could be looking, because of the amount of current going through this glass structure hitting the negative here, that could be the ether reaching out from the negative electrode through space to extinguish these quote electrons, these arcs, early before they even get to the absolute 0 voltage state. Just a thought in what I see in terms of mechanism and order. That's where I'm coming from.
What do you think's extinguishing it?
The resolution of charge itself, going from a very high voltage state to a very low voltage state, and this is the gas that it is operating through in terms of its ability to catastrophically fail in terms of capacitance.
Moreover, in rarefied air, it is observed that a violet light surrounds the negative electrode and a deep red light the positive, which reveals the true difference between the positive and negative electricity. Since violet light has a higher frequency than red, this means that the electrogen acting on the rarefied air and causing it to produce violet light is in a state of vibration of higher frequency than that on the positive electrode, causing the air to emit the deep red light. In other words, the negativity of an electrode is given by the frequency of vibration of its electrogen, and the lower the frequency, the more positive its character is.
Instead, that could just merely be 2 different accelerational, decelerational gradients on their way in and out of physical space. That would actually result in 2 parts of the spectrum being related to us as a part of the acceleration and decelerational function. Just another thought.
All right, Alan, could you scroll down, sir?
Absolutely, my good sir. All right, here we are.
A helpful way to visualize the surplus of electrogen on the surface of metals is shown in the picture below, taken from a video made in 0 gravity, the ISS.
God bless NASA.
The water on the cloth corresponds to the electrogen and the cloth to the metal itself. A metal with electrogen deficit will then correspond to water trapped within the cloth. Okay.
But to complete the analogy, it's actually the squeezing, the twisting of the cloth is applying voltage to the cloth and causing the electrogen to come out
Yeah.
and go to other places.
Yeah. Pressure on it. Yeah. When the electrogen travels along the wire as a diffusion wave, it constitutes the direct current as shown in the picture at the left and discussed in length in parts 1 to 3 of this series of articles. So negative, he's saying electrogen surplus. Positive, he's saying electrogen deficit. Electrogen diffusion wave moving through the wire. In the remaining part of this section, will be considered examples of electrostatic phenomena and their explanation in terms of molecular vibrations. In order to show the excess of or deficit of vibrating electrogen on the surface of an object, I will use a representation similar to the electrical density, which was defined as the quantity of electricity per unit area at a point on the surface, and called by Poisson thickness of electrical stratum. Examples of such representations are shown below, where it is seen that the distribution of electricity on a conductor depends on its form. There's distribution on a sphere, distribution on an ellipsoid, distribution on a disc, distribution on a cylinder with rounded ends. In our case, electrogen excess will be shown as above, with blue-colored lines above the surface of the object, while the deficit will be shown with red-colored lines below the surface of the object, which means that, in this latter case, the atoms of the object at the surface will not be covered by electrogen. Well, let me read that again. Okay, got the diagrams above, got blue contour lines above the surface, like those little dashed lines. But the deficit will be shown with red contoured lines below the surface, which means in the latter case, the atoms of the object at the surface will not be covered by. Oh, he's saying like it's going to be within the material. Okay.
It's like a sea level line.
Yeah. I had to read it a second time to make sense. I see what he's saying. Yep, right there. Okay. One, attraction between a body positively charged and one negative. Oh, he's going through the 6 cases again. Okay, so one negatively charged, one positively charged, while a molecular vibration formulation is attraction between deficit of electrogen and surplus of electrogen. Oh, it's wanting to osmose through the barrier of the surface, is what he's basically trying to say. Like because the electrogen is like separated by the physical surface, it's trying to. Okay. Oh,
It's that when it has an excess, then it is emerging beyond the surface of the material and now moving around over the surface of the material. When there's a deficit, it falls within the material and looks for more.
Right.
Oh.
Yeah. Okay. Oh, can you just go back up
Oh, yep, my
real
bad.
quick? I just wanted to see if that stuff on the right is vibrating atoms black at the surface of the object A interact with vibrating electrogen blue on the surface of the object B. The sizes of the vibrating objects are different, so attraction occurs irrespective of the frequencies of vibration. Okay. Got it. Next example, one positive, one uncharged. Oh, is it going to be like at the surface? Okay. Attraction's going to, can you scroll down? Yeah, at the surface versus inside. Because even at the surface or above the surface, it's still going to attract. It's probably going to be slightly less attraction, but still attract. Okay, makes sense. Scroll down.
No, actually, I don't think it makes sense when you got this red line. This is the part where I'm like,
Well, it's almost
guys.
like it becomes a vacuum when it's inside the barrier, and it's like it becomes like a pump when it's outside the barrier kind of thing.
Well, I just think there's
Or
no
blower.
such thing as a deficit. I just think that it is either charged or the charge is resolved and it has no charge. There's just far too many classifications here for my taste.
Yeah, what would the deficit represent? Like how would it be
It's a
less than zero?
non-thing. For me, there is no such case. You know what I mean? It's either it's charged or the charge has been resolved and it's neutral. It's grounded. You know what I mean? It's got a voltage state or it doesn't.
Mm-hmm. What if electrogen actually can't be transferred? What if it's just the like the pressure on the electrogen that's transferred, which is just the vibration, because the vibration is what's causing it? So what if what they're transferring is literally just the vibration?
Too many what ifs. I'm not even tight on this paradigm. I'm having major fundamental problems with these mechanics.
Yeah, I'm just thinking his fundamental reason for this. Well, I don't know what his fundamental reason. I think some of the fundamental things he's addressing that I agree are flawed are the whole idea of two types of electricity, where like charge is just like one thing in my mind. Like that's what seems.
Precisely. That's exactly what I'm talking about. So if charge is just one thing, we wouldn't have 6 classifications of relation between things that are and are not charged.
But right, if charge is only one thing, how do you have both attraction and repulsion? Right, like that's kind of the what he's trying to address.
Well, that's about equal charge, right? If you've got two things that are basically charged to the same quantifiable amount, then obviously one cannot resolve its charge by coming closer to the other. There's no ground potential to relate to because they're both charged. The mathematics are entirely far simpler when you're looking at it. It's one-dimensional almost.
So you're saying when two things are equally charged that they would repulse?
Well, they would repel because they would be both looking for a grounding point, and that's not each other, right?
Okay.
So this is all about the lines of force that they would emit, this according to R squared yet again, in terms of static charge.
Oh, you're saying the
The
lines of force
electrostatic
would be
charge.
equal, so they wouldn't be able to like interact meaningfully, so they would like push off each other instead of like affecting each other.
It's that their voltage state, yes, their lines of force are equal in force, and they are equally ready to ground out when they find it, but they're not going to find it in each other because they're both charged to the same voltage state.
Hmm. Okay. Is this why? Do you think this is why there's more cases of attraction than repulsion because there's a less chance of them being the same charge state than different charge states?
And far more chance in physical reality to find something to ground out to. Yeah, something that is a much lower state. Because they're dealing with very high voltages, especially with that stripy snake, that infected snake thing we were looking at. I mean, depending on the size of that glass, you're looking at thousands of volts to get the arc to actually happen, right? I mean, it's all a snappy diagram. I don't think they actually built one with 5 snake or 5 bends in the way in the middle channel like that. That's a really hard thing to build in the 19th century.
Have
I
you
don't think they went
observed
that far.
Have you observed the phenomenon he was describing though, with like one electrode making direct contact and the other one having a buffer gap?
Say what?
Have you observed what was in the snake diagram where like one of the electrodes has like what he labeled positive has the arc like directly touching the metal, and the other one has like a gap, a buffer gap between the arc and the
You
metal.
know, I actually haven't taken the time to get the microscope out to look at that. No, I haven't. But
What have you been doing instead?
I'm
I don't understand.
I'm taking
Sorry.
as wrote the prime observation. Like he's saying, when we hit it with voltage, this is what it looks like. I have no reason to doubt that part.
Okay.
Well, so we're definitely not going to get through this whole paper tonight. We've been going for a long time now.
40 pages.
Yeah.
Well,
Let's finish these 6 cases real quick.
You're halfway.
How
I'm
many?
impressed,
6?
man.
Yeah, we're on case
There
3.
are 6
out of
cases, yeah.
Yeah,
6
so there's
cases.
that one
Okay.
is
I thought you said
that-
6 pages. I'm like, dude, wait.
That-
I just
that
said
one
we
is,
can wrap it up.
charge
Okay, yeah.
at the surface versus charge beyond the surface. Okay, so that's attraction. Okay, go down. And then this one is charge inside the surface versus charge inside the surface. So you got like 2 vacuums sucking at each other. So
I see. Personally, I see 2 totally resolved charged particles there. They're both grounded out. They don't have deficits. They're just at a 0 voltage state. So they're not going to repel or attract each other. There's no vibration going on. There's no excess to consider.
Yeah. Okay. V. Can you go down the next one? Oh wait. He says the sizes of the vibrating objects are similar because the substances are identical or the molecules have similar size, so they vibrate with the same frequencies. Phase synchronization occurs, so repulsion occurs irrespective of the initial phase of vibration. He's attributing it all to vibration. Okay. The illustration's kind of wonky.
But he's never putting his finger on the vibration.
Right. He doesn't
He's
actually.
never quantifying the vibration. He's never talking about the amplitude of the vibration. None of that.
Yeah. This is like paper number 4 in a series. So I would wonder if he has any experiments to point to. Repulsion between two negatively charged bodies while in molecular vibration form. Yeah, okay, that's the outside, and there's repulsion between those. So he's basically saying if you find two like states, they're going to repulse. And then can you go down to number 6? Then two like states just of slightly different magnitudes create attraction. Okay. So even with like
the reason that they create attraction is because in the uppercase, A is much more charged than B, and A sees B as a place to at least partially ground out until both of them achieve the same or lower for A, higher for B voltage state.
What about the bottom half?
Well, the bottom half for me is a null issue because you're seeing one that's grounded on the B side and one A says the supposed deficit, which I don't think is a case that exists.
So how? Okay, I am wondering though. Like, don't if you take an oscilloscope, right, or like a voltage meter or whatever, is there such a thing as negative voltage or negative charge? Like if we take these.
We're actually just looking at the concept of negative polarity, but all of that has to do with a floated voltage state to begin with.
You're saying the zero is not really zero?
It's actually as negative as you're going to get away from the positive voltage state, whatever they're coming out of the red wire. Yeah. The black wire is actually the 0-volt wire. But in terms of positive negative polarity, it's negative from the perspective of the positive. But there's no such thing as negative voltage in that state. It's just 0 or however much positive voltage you got going on, which is all trying to find the 0 voltage state.
Okay. Okay. Got it. See the 6. So that's case number 6, which is the one he was saying was kind of the crux.
As more the direction on the integer line, nothing more. No, that's what negative is.
Well, it just seems like if one is 0 and one's highly positive, they're going to attract. But then if you compare another set of two that are also different.
If one's charged to 2,000 volts and one is charged to 20,000 volts, the one that's charged to 20,000 volts is going to try to ground out until the both of them are at 11,000 volts, right?
Yeah.
That's just natural charge distribution, the way that it seeks to find ground. And that's what we're seeing in the uppercase here.
So it's the negative case, like two sets of lower numbers, like 1,500 and 500 or something?
As long as there's a difference between them and both of them are non-zero, you're going to see the uppercase. But you're never going to see the lowercase because there's really no such thing as the red A, the lower red A. There really isn't a below 0 voltage state. There's charge or there isn't. You know what I mean? It's a question of relation. And if the integer relation is moving to the left on the line, as in less charge, people see that as negative relative to the positive.
Okay. All right. Scroll down. Thank you, sir. Oh. I can see Alan's finger just going crazy right now.
He ended that section with a chart.
All right, there we go.
Yo, so we tapping out, boys?
Yep.
Let's
Wrap it up there. So, real quick, just one last chance. Anyone want to make any final comments or questions regarding any of the stuff we read tonight?
Oh man, I'm not too entirely sure.
There's a lot. Sounds like there's still a lot more to talk about with this one. That's for sure. But we'll have to pick it back up at some point here.
Dude, yeah, we'll definitely be coming back to it for sure.
But we're gonna go ahead and cut the stream. So just for final words here, thanks for being here, listening to Reading Night and all the discussion. Thank you especially to Piezo and Stone for all the insightful discussion on this last bit of this paper. That was nice to listen to and have some back and forth on that. And tomorrow night, join the Levelheads on X Spaces for Flat Earth Fridays, or tune in to the stream live on Space Audits or on ADL. And then on Sunday evening, we're definitely going to do another Bring Your Own Brenner Comp reading night. I know we said we might do one last Sunday and then we didn't. We're definitely going to do one this time. And what we do then is we just read work from Michael Brenner's Quora Answers. So you can look up Michael Brenner on Quora. His profile picture is a black background with a red eye, and he answers a bunch of questions to a bunch of things related to cosmology and physics and ether and a bunch of other things. And his work is quite well researched. Highly recommend checking it out. If you want to go find one, bring it here to the Discord server on Sunday night and read it. You are welcome to. We will be live streaming that. And then next Tuesday, geomagnetism, I will be giving a presentation regarding the magnetic field of the Earth. So tune in for that. Thanks everybody again, and take good care of yourself.
Yeah.
Ta-ta.
I'm gonna go ahead and